This lesson is on using the Pythagorean theorem and distance on the coordinate plane to find area and perimeter. Previously, we used the Pythagorean theorem just to find the distance between 2 points on the coordinate plane. Now we're going to take that a step further and use it to find the area and perimeter of shapes that are drawn on the coordinate plane. So in this first example, we have this triangle and it's kind of catty corner. I don't know that it's a right triangle. I don't know that it's not. But I do know that I can use right triangles to find all the side lengths. So we're going to work on the perimeter first. When we work on the perimeter, what we want to do is draw a right triangle off each side to help us find the side lengths of the triangle. And you'll notice that we've kind of created ourselves a rectangle here. So let's start with that red right triangle that we've created. We have a leg of 4 and a leg of 9. Be careful that you count those correctly. So what I'm looking for is that hypotenuse. So I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, to find that long side. So 16 plus 81 is 97. I'm going to take the square root of both sides. And I'm going to get that c is 9.8. Now let's look at the blue triangle. I've got a leg of 3 and a leg of 7. Again, I'm going to use the Pythagorean theorem. And that's going to give me 58. Take that square root. And the hypotenuse of that blue triangle that we created is 7.6. And then we can move on to the green triangle. Take the square root of both sides, and that last side of our original triangle is 6.7. Now, for perimeter, we add all the sides, right? So perimeter is going to end up being 9.8 plus 7.6 plus 6.7. Notice that I'm using the sides from my original triangle, not from the triangles that I created. And when I add those three numbers up, I get 24.1. So the perimeter is about 24.1 units. Now we're going to look at finding the area of this figure. Now when we find the area, we're looking for the area of just our original figure, which is inside this triangle. But because this is a right triangle, I don't know necessarily what the base and the height are. So instead of using 1/2 base times height, I'm going to use the rectangle that I created outside of the triangle to help me. So I know that the area of this entire rectangle is going to be 7 times 9. We've got a length and we've got a width. Let's go ahead and mark that we're finding area. I know that the total has to be 9 times 7, which is 63, and that's going to be important. Now, because we only want to find that gray shaded region, I have to take away all of the other regions. So I have to find the area of that red triangle. Well, since it's a right triangle, I know that I've got the base and the height. So 1/2 times 4 times 9, or 1/2 of 36, is going to give me 18. So this one is 18. Now let's look at the blue. I've got a base of 3 and a height of 7. Which gives me 10.5. And now we'll take a look at our last outside triangle. I've got a base of 6 and a height of 3, or 1/2 of 18, which is 9. So these are all the parts of the triangle that I do not want to include. I only want what's left in the gray region. So I am going to take my total area and subtract 18, 10.5, and 9. It's easier to add those up first. So the whole rectangle is 63 units squared. We used 37.5 units squared for the triangles that we added to the figure. So now we need to take them away, and that will give us what's left in our original triangle. So the area of our original triangle is going to be 25.5. Now we'll look at the next example. And again, we're finding perimeter and area. And we'll start with the perimeter. Once again, our first step is to draw those right triangles to connect and create the hypotenuse. So now we've created our 3 right triangles, and we're going to use them to help us find the sides of our original figure, which are these sides right here. And we're going to use the Pythagorean theorem to find each of those sides. So now I've found all the sides of my original figure. And to find perimeter, we have to add all the sides. And that will give me the entire perimeter of that original figure, which is 33.6. Now we're going to look at finding the area of our original figure, which is this orange shaded region inside the triangle that was already on the coordinate plane when we started this problem. And again, we're going to find the total area by using the area formula for a rectangle, which is just length times width, which is going to be 9 times 13, or 117. And we're going to take away each of these outside triangles that we created. So we're going to take away the blue, green, and red regions of the rectangle so that only the orange is left. So starting with the red, 1/2 times 6 times 8. 6 times 8 is 48. 1/2 of that is 24. And then the blue is 1/2 of 3 times 13, which is 19.5. And lastly, the green is 1/2 of 9 times 5. Now I'm going to take each of those away from the total, and that's going to give me what's left for our orange region. So the 3 triangles we're taking away are 66 units. 117 minus 66 leaves me with 51 units squared. So the area of our original triangle is 51 units squared.